Just you start, yeah.
Yeah. So, hello and welcome to yet another webinar lecture of our webinar series. As you know, this is actually the second session of our webinar series, and is being conducted by uh, it is being conducted by JIS Institute of Advanced Studies and Research, Kolkata. So, for the attendees who is joining for the first time in today's webinar, let me give a very brief overview of our institute. So, JIS Institute of Advanced Studies and Research, in short, it is called JIS IASR Kolkata. This newly formed institute was actually established just a year ago in Kolkata under the eminent leadership of Professor Ajoy Kumar Roy, and under the flagship of JIS Group. Our prime objective is to undertake the promotion of translational research in the field of computer science, health science, and several interdisciplinary sciences that include material science, polymer, sensor, and IoT. So presently, we are offering mainly postgraduate and PhD courses. So the uh, uh, process is now ongoing. So this institute is growing since its inception based on the translational research. So we also have a strong group of exceptionally talented and experienced faculty members. So I'll today now we are going to have two back-to-back lectures in today's webinar. As you know, today there will be lectures on IoT, that is Internet of Things, and cloud computing. The speaker of this lecture is Professor Ajoy Kumar Ray, our Honorable Director of this institute. And the second lecture will start just after the first one at 4 o'clock, and it will be on fundamentals of data science and its application. The speaker is Professor Shuman Sengupta. So without taking much of your time, I just now move on to our first lecture to be given by Professor Ray. So I would request Professor Ray to take the platform, and you can start. Sir,
So
yeah,
a
you can.
very good afternoon to all of you, my dear students and faculty members. Today I'm going to talk, it will be most of, predominantly an introductory lecture on the one of the most important topics of today, that is IoT. IoT means that Internet of Things. Now, Internet of Things, you all have heard of it. The first thing that comes in mind is, let me just go to the screen sharing, and that what is this, the meaning of these things. We say that, okay, Internet of Things. I do not know how much time I will get to cover cloud computing, but then let me make a modest attempt. So Internet of Things, the most important thing that comes to mind is, what do you mean by thing? Now thing means it may be any physical object, it may be the cot on which you are sleeping, it may be your table, it may be your chair, it may be your laptop, it may be your cell phone, and for that matter, it may be anything on earth. So the first question that comes to mind is, how do you do the Internet of Things? In fact, the next version, everybody, the name is Internet of Everything. Now we understand that, okay, initially the Internet was being used by the human beings. So today we have got about, if it is 7 billions of people all over the globe, then the total number of Internet of Things has already crossed 20 billions right now in 2020 early. So it is almost, 3 times the total number of human population on the earth. So this particular subject, it assumes a very, very important significance simply because of the fact that internet is no longer the internet of the human beings where you and I, we all are connected. But then now the things also are connected. I'll come to the point that how everything can be connected. We were connected, we understand that through our mobile we are connected, through our laptop we are connected, through our tablet we are connected. But then now all the things, through all the things we are connected. Now, let's go to the important now these Internet of Things, as I was just mentioning that there will be 75 billion IoT devices by 2025. That means in the next 5 years. 75 billion means what? 1 billion is 100 crores. The total population of India is 1.3 billion. So it will be 75 billion things which will be connected. The proliferation of IoT products will be so much that it will flood the digital universe with unprecedented speed, which has never been seen before. And now, a recent estimate says that every person in the next 5 to 10 years, every person will have about 5 to 6 such devices which will be connected. Imagine that in our country, we are not considering the large number of rural population, a huge number of population in the whole globe, they are much below the poverty line. So we are talking here about only those who can afford. Now the proliferation of such IoT products, this will lead to lots of problems of connectivity, communication, and then the most important thing, that is the analytics. So I have written that with the aid of 5G network, which is coming very shortly, hopefully maybe that now due to Corona, I do not know what is the situation, but then it is expected that by 2021 or 2022 latest, even in India we'll have 5G network. So already we are in 4G, and with proliferation of IoT devices, so there will be a massive surge of the data. Let's see the, so industrial systems, IoTs are of two types. One is known as the industrial IoT, the other one is known as consumer IoT. You and I, we always, whatever the sensors, etc., we will be using, they will fall under the category of consumer IoT. Let's now see that industrial IoTs, that will be the backbone of Industry 4.0. You have already heard of this term. Everybody now today talks about Industry 4.0. And one of the major planks on which the Industry 4.0 will rest, that is on the industrial IoT. There are a large number of very important projects which are smart city project of the not only government of India, in many cities around the globe they are making this big project. I say that it is smart city cum smart village project, because in the villages also we need to implement more of such IoTs. So IoTs for villages, for agriculture, for rural development, it will play, in my opinion, a very big role, and lots of jobs will be generated if our government if they can give a little bit of more attention to the IoT in the smart villages. In cities, we have got smart buildings, and the vehicles today are becoming more and more smart. As you all know, that we have got even human, we do not require any human for running the Tesla kind of, the cars, the motors. Medical systems, healthcare is becoming and will make use of a large range of sensors and devices which will be connected. So all these things, so the basis is here sensing or the sensor. Let's see now that what this really means and what is the definition of Internet of Things. So there are large number of definitions. In fact, every industry, IBM has got its own definition. Intel, it says something, more or less it's the same thing, but internationally there is a body, that is the Telecommunication Union, ITU. So they say that global infrastructure for the information, which really enables the interconnection of physical and digital, virtual things, using existing and evolving technology for the betterment of society. So this talks about everything. That is, there are two things. One is the physical things and the virtual or the digital things, which are already existing. That is the computers, laptops, mobiles, and all. So it will be an interconnection of these using whatever technology is existing today. And more importantly, new technologies are coming which are evolving, and these all are useful for the betterment of the society, because tomorrow's society cannot move without IoT. So world population, this I have given just a sort of a comparison, that you can see that by the time we were 2007-8, okay, that time only, that is about 12-13 years back, there were more connected devices than the total number of global population. It is today 7.6 billion in 2020, but then in 2003 it was only 6.3 billion. In such a short time, in 17 years, the population has increased 1.3 billion. That means the whole, assume that in 2003 India didn't have any population. In 13 years time, as if, the total population has increased by 1.3 billion. That is our current population. So you can see that how the connected device per person is increasing. It was 0.08, less than 1 in 2003. But then it became 1.84 in 2010, 3.47 in 2015. And as I just said, that in 2020, we have got almost 6.6 on the average devices per person. That means as if I have got 7 devices which are connected to the internet. You have got 7 devices which are connected to the internet. And this is now going to increase and increase. Of course, those who are more, the rich people, they can afford to have much more such things. But this is the current reality. And currently the connected devices is 50 billion and the world population is 7.6 billion. So one thing is we have got change, and change is the only thing permanent in this world. So let's now see that what is a network of networks. What is the meaning of that? So suppose, let's take the case of transportation.
Sir, sorry to disturb you, sir.
Yes.
Can you please make your slide full screen so that viewer can see better?
Oh, acha, right.
Yeah, sir.
Yeah, I'm making it full screen.
Yo, okay,
Yeah,
okay.
so I'm sorry. Is it now?
Yeah. It is visible now.
So this transportation, transportation around the world, it's a very, very important thing. Assume that we have got an Internet of Things in the transportation sector in India, or maybe that in Calcutta only. That means in Calcutta, every day from morning to night, the number of vehicles which are moving, the total traffic congestion everywhere, the total, delay at the major crossings, the average number of vehicles on each road, the average number of accidents in the city. So lots and lots of such data are there in transportation sector. So we can have a separate network which just talks only about the sensors inside the vehicles and from the transportation department of the government. Similarly, energy. Energy is now today a very big issue. The different, for example, how much amount of production, energy generation is there, how much is the consumption, how much amount of, wastage, how much amount of energy theft, how much amount of renewable energy, how much amount of non-renewable energy, fossil fuel based. So lots of such issues. Like energy, I haven't written. Another important thing will be environment. Earth, the geospatial data, big things, lots and lots of data is there, and that will be available. In your home, simply in your home, if you want that all your lights, your fans, we always, forget to switch off. In the classrooms, we forget to switch off the lights. Even in our rooms also, the fans are on, and your mothers will shout on you that all the time it's off, it's on. So home is a big thing. Education is a big sector. Business, where lots and lots of jobs will be created. So everywhere they are connected. What are the issues? Now, these are all separate nets for their own purpose. Now, we have got a network of all these different networks. As you can see, that individual networks are 1, 2, 3, 4, 5, 6, 7. There are many others. Now, they will be connected, individual network, because transportation is dependent on energy. Because without energy, our, the rail, the transportation will not be there. Similarly, the homes are connected with energy, education and home, they are connected. So everything is connected with others. So it's a network of networks. What is the main issue? Main issue is security, because you have to ensure that the data that you are procuring, every moment it must be secured, and while communicating, it must be securely communicated. And the other two things is analytics and management. This I will come in a short time. So let's now see the benefit. So we had talked about earlier, we are getting now data. Now you have to just think about, take any sector from the data, how, just you think about, don't use any computers and all. How can we get the information from the data? Imagine that, okay, in your college days, in your final year, in your third year, in your second year, whatever marks you have got, whatever sports you have played, whatever extracurricular activities you have done, whatever, the other things you have done. So the point is, in everything else, you try to get the data, and then from the data, try to find the information. Similarly, information leads to knowledge, knowledge leads to understanding, and understanding leads to wisdom. Everything now will be done by computers. So that is what is the technology. Earlier we are talking about, data. Still now we talk it about data science. So the science of data leads to an area where the data will be converted to not only information, it will be converted. What is knowledge? Knowledge comes only from large number of such data or from some information. And once you have got the knowledge and knowledge in different domains, you get an appropriate understanding. Finally, wisdom is a very, very important stuff which will take time. Now, let's see that what happens with when these 50 billion machines become connected. So, hospital sector, shipment, okay, then factories, the logistics, things will move from one place to another. Logistics is a very, very important thing. So, hospitals now become smart hospitals, rail yards become smart rail yards, power sector becomes smart power sector, factories become smart factories, our academic institutions also become, so far it was not smart, now we have to make them more smart. So everywhere, if we have got a smartness, then, for example, the energy sector, we need the smart grid. How do you get it? Again from IoT. The different types of sensors will give you the information about how much amount of energy we are generating in each sector. Smart grid, what does it do? Smart grid is maybe even AI and machine intelligence can be applied to smart grid to say that if suppose you are generating power from renewable energy, from solar, you are generating power from conventional fuel cell based our CESC energy, you are generating power maybe from wind energy, and tomorrow's energy will be also from other sectors like say biomass and all. Now, how will you use that energy? Everything goes to the grid. Your solar energy can be sent to the grid. Now, how do you want that, okay, in the top peak hour, how much amount of energy you will use in each of these sectors? You need IoT. Without IoT, you cannot do that. So I'm just only, before coming to the actual technology, let me just see a very interesting thing, that is the value of the industrial internet, which is so huge today. So here in this slide, it has been shown, this is, done by General Electric. So they say that if we can estimate only 1% savings because of implementation of IoT, then the whole industry-wise, your estimated value will be in aviation industry $30 billion. I do not know whether you have got any idea about 30 billion. Frankly speaking, we cannot even think about. The whole countries, like India, it's not in rupees, it's in dollars. So it is 3,000 crores dollars. So 3,000 into 70 today. This much of money in rupees. Power sector, 66 billion. Oil and gas will have huge amount of, after implementation of IoT, it will have 90 billions of dollars of capital expenses which will be saved. So the government, the industries, the society as such will have to, today or tomorrow, implement IoT in a very, very big way, because this is the technology of today and tomorrow. So what is this massive potential of IoT? We have to now see that how we can unlock. This is a locking period, everything is locked. So how do you improve the performance, create the innovative services and such kinds of things? Every time you have to think about the revenue stream, how it will be increased, and the cost of production, how you can reduce that. Again, IoT. I'm starting it with a very funny, with a very funny slide. I think some people will be very happy. That is in the holy cow. Now in India today, cow is the main thing. So how the cows, the milk production can be increased by using IoT. In the ears of the cow, you implant some sensors, and that will give you the location of the cow, where the cow is, and that will give about the health parameters of the cow, and that using AI, you can, in fact, I'm thinking to write a project on this, how you can make a healthier cow so that it can give more milk. In fact, this project, I'm sure that the government of India will catch this project. So a cow generates about 200 megabytes of information per year. So imagine that only a simple cow, and it has got so much of things. It's on, once it's there for cows, goats, and everything which is. So even the animals. So jokingly, while I was in Shipur, I used to tell that your dog will talk via internet with my dog tomorrow, and that will be just the the state of the things through IoT. So what are the networks of devices, and how, what are the important things? One is, as on today, in very large number, which is being used, not today. In fact, it was being used from late 90s, tagging things. Many of you must have heard about RFIDs, and this is using radio frequency. Your location can be identified and you may be traced very easily. For example, in a big mall, it has got lots of examples. In a big mall, you want to see a certain things. First of all, you have to know that, okay, this is in third floor of the mall or on fourth floor of the mall. Where is it? Then, where does it, where is it located? So one thing is, everywhere it's written that, okay, here you will get the toilet kind of things, here you will get the beds, here milk. But then suppose you do not know, even to identify where is the milk, you have to ask somebody, Acha, Dada, milk ta kon dike ache? So you don't need that. So RFIDs, or there are sensors which can tell to your mobile that, okay, I am here. So you can do the tracing, so traceability of the things, because imagine that the owner of the big mall, so that big bazaar or those, today there are lots of such malls. At the end of the day, so many things, they have to take care of, whether, everything is in order or not. Suppose we take suppose somebody wants to purchase a pant, we go to that small room, change it, and then we find that, okay, it does not fit you, you need another one. So even a shirt you want to purchase, so what is, and you keep it somewhere. So you have to trace it. So how do you trace? So in RFID, you have got a tag and a reader. So this was a very simple kind of things, and even in the library, the books, you have got a tag, and then you can read that tag, and then you can find out. Even in the big malls today, you purchase the things, and when you come to the counter, they will see your tag, and then they will, through the reader, that will be read. That is the purchase, this is the, the price of that. So this has now come to a much, much bigger level. So tagging things today in a supply chain management, this I talked about only small things. Suppose in a very big industry, there are so many different types of objects. There are so many parts of an industry which have to be, sub-parts, then again the component level things, and you have to locate everything, and everything should be in order. You cannot do it without using the very sophisticated technology using IoT. So IoTs come in a big way for localization of things. I have written tagging means that localization of things. Filling things. So filling things means sensors act as primary devices to collect the parameters from the environment. Filling means what? The temperature. That you have feeling that it is hot today. The rain, the moisture for agricultural people, everything, environmental things we have to fill. And now, only sky is the limit. You can think about a sensor which can sense any kind of parameter that comes to your mind. Think about, and then you will find that it has got no barrier, no boundary. Only sky is the limit. And sensing is the most important thing, and sensors are closely related with IoT. So without sensors, there cannot be IoT because it becomes otherwise simply internet. So feeling things by sensor. Even RFIDs are also kind of sensors. Shrinking things. Now this is very important because whatever you do today, the electronic sensors, the computers, they have to be micro or nano miniaturized. So for making any smart device, they must be very, very small using nanotechnology. This is of course another level of technology. I'm not going into it, but shrinking things is also very important. And it comes under IoT because even as user of them, we want that it should be very small in size. Thinking things. That means the sensors which can think the internal kind of things. That means the smart sensors. So embedded intelligence will be kept inside the sensors. Let's take a camera. A camera you have purchased from the market. So automatically, I want that the camera should be able to automatically take the images even if it is at night. How does it do it? So it must have a sensor which senses the ambient light. Once the ambient light is sensed, if it falls below a certain threshold, then that kind of sensor camera must have the IR, LEDs. So those will be sensed, those will be put on automatically. You don't need to do anything. All that you need to do is today, you have to do this, that, and all. You don't need to do anything. Automatically, the IR images will be obtained. Now, IR images, again, they may not be RGB images. They may be black and white, gray level images. But what you can do is, you can get even the RGB images, that is, we get in a colored camera, using the cameras even at night. So again, for that, you have to make an intelligent camera. So today the cameras which are there in many places, in fact, now they are becoming a little bit intelligent. In Calcutta roads, you will find that for traffic, there are cameras. So the initial work on those cameras were done by, in fact, I was fortunate to be a part of that group in America. And they have now dismantled and they have started a group again in India. And they are the people who have kept a lot of, in Salt Lake city center, in Salt Lake sector 5, you will find all those cameras. They are all intelligent cameras. But then now more and more intelligence has to be put there. So IoTs, they have got many challenges: scalability, technological standardization, interoperability. I'll come to all those things while talking about the IoT. Software complexity, data volume and data interpretation, power supply of these devices, wireless communication. So it is very, very, huge amount of work involved in this. It must be fault tolerant, and wireless communication and short range wireless communication, even big range wireless communication is the major part of it. So let's see that a connected city problem. So before going into the connected city problem, which will be a little bit, or this is, the distributed device data, I will come straight to the IoT system architecture. Now this, in IoT system architecture, here we have written the plans, that is the factories. This can be commercial level, this can be my house, this can be me only carrying some of the devices, sensors with me. Like say constantly I can have one IR thermometer with me in these COVID days, which can take the thermometer, my reading. I am now on the road in Calcutta, and then immediately it can be connected to the gateway, as we call it. We have written here hub. Hub is nothing but gateway. That means all these devices are connected to a gateway. So I have to now explain what is this device, what does it contain, what is this gateway or hub, what is now from these gateways, directly you can send the data to the cloud or to the internet. But then intermediate, you can see that I have kept one fog processor. This is very important. Now fog architecture is a major architecture, and in many of these IoT devices we have got the fog processors. I'll talk more about that. But then, so what are the things? I have got some device. What is this device? This may be simple. Simplest may be say temperature, pressure, different types of sensors. What are these sensors? One may be say environmental sensor, that is temperature, wind pressure. We can have, and you talk about any kind of sensing, the sensors are available. Unfortunately, most of these sensors again are coming from China. And then we are purchasing it from the market. So sensing, we are giving more stress. We are trying to make a sensor hub in our new institute. I'm sure that with the help of many people, a lot of things can be done. And we are making a big sensor lab. All kinds of sensors should be available there. Now, these kind of sensors, they are constantly collecting the data. And that data, whether it's environmental data, it may be your health data, it may be biochemical data, which is very important, I mean, the sensing of biochemical things. Like you might have seen that from IIT Kharagpur, one of my colleagues, Professor Shuman Chakraborty, Professor Mojumdar was the head of that School of Medical Science and Technology, then I took over, then Shuman took over. So Shuman has now today a COVID rapid, not rapid testing kit, it is, the actual COVID testing kit from the RNA of the virus, he has made it, and very low cost. So PCR is the thing which are very costly, some 20-25 lakhs, but this costs only 20,000. And for checking the COVID, which the government cannot do now, and it will cost only 400 rupees. How do they do it? It's again sensing. So sensing, what sensing? Sensing means because of some kind of protein from the RNA architecture of the COVID virus, it will change because he works in micro channels, microfluidics as it is called, using some simple paper technique. So the paper colors will change, and if you can find out that how much the color change has been done, then from that color change, you can identify that how much amount of COVID virus is there in your sample. So it's so simple. But then it needs the mind to think and using simple devices, because Professor Chakraborty has been working on this area for a long number of years. That is, he was working with microfluidic channels, mechanical engineering. And today, this has found a good application, because from the RNA, you have to keep the RNA from the COVID patient, extract the RNA from the DNA, and then you have to check it. So interesting thing is that now every different types of devices, industrial devices again will be different. There will be more of electromechanical devices. So they are all connected with the different hubs. So hub means gateway. Now, first thing that comes to mind is, this hub that we are using, or the gateway, directly, why can't we transmit the data to the cloud, to the internet? It could be transmitted. So see, on one side of the hub, there is from the device, the data is coming. Now this kind of data which is coming from one side, this is a simple data. That is in a simple, maybe that so many devices are connected, it's a LAN device. But then on the other side of that gateway, what the gateway has got? It has got a switching. You can do the routing, because from so many devices the data is coming. Each data has to be kept in separate things. From somewhere the data is coming about the environmental data. from somewhere the health data. So it has to be given, each device has to be given addressing, because when the number of such devices goes to billions, you can easily imagine that addressing becomes now a big issue. You know, in internet, we have got, every one of us, we have got an address. Okay. So here also addressing in billions, it has got a, so there are techniques again. In 1 hour's time, nothing can be done. We can discuss later on addressing things. Switching, routing is very important, because it is a, so both these things, fog and hub or gateway, you can think that, okay, both are same, more or less. Hub is of much lesser computational complexity. A gateway or a hub, it can be a simple Arduino board. It can be just some ARM processor based board. It can be, Edison from Intel. They have got their Edison board, Galileo board. These are all available in the market today. Raspberry Pi, the Beagle board. In fact, all the companies, they have come up with their own boards. And on one side, we have got, so the inside the hubs have got maybe connected with any of them. And the operating system that is used is Ubuntu operating system. This is a free software and you can download it, and it's very good. It's a Linux version, Ubuntu. It can be used in your laptop, in your tablet, mainly in your IoT devices. This is very, very common. From the hub, you can directly connect it to the server, that is to the internet. Now, why not from the device you can directly connect to the internet? That is because the device, for connection to the internet, you need a certain protocol. Now, those of you who are new about protocols, protocol is a very interesting thing. You will find that today we are flooded with protocols, so many protocols. For connecting with the internet, you need TCP/IP protocol. So in the computer communication jargon, we call it as IASR. There's the International Standard Organization, ISO. So ISO has got ISO OSI. It has got a 7-layered, architectural protocol. So out of these 7 layers, few layers have been taken by internet. So this is known as TCP/IP protocol. Now the devices are so small devices, they have got inside the device, there is nothing. That's a small processor. It can do very little processing. Processor means it may be a microcontroller. You can purchase it tomorrow from the market. Make the device sensor, microcontroller, and some kind of a radio transmission. If you want to have some kind of a, such things, like say you need to send the data through maybe the different wireless mode, like say you can have the Bluetooth, you can have the Zigbee, you can have anything. So many, n number of things are available in the market today. But on the one hand, on the hub, we have got all these different simple, the through lines. It may be wired, it may be wireless. Information is coming. So what does the gateway do? It does the translation of the protocol. That means from device using simple protocol, the data is coming to the gateway. Gateway is converting it to TCP/IP protocol to send it to the cloud. So this is the whole thing. Now, how to do this translation of the protocol? That is again a very interesting thing. I mean, for the last 30, 40 years, people are using this protocol translation. That's a very interesting, kind of work in the domain of computer communications. So then what can it do? These gateways, it can do switching. It may be routed to certain areas. It can do the protocol conversion, as I said, very important, from simple protocol which is understandable by the device, it will have to be converted to TCP/IP. Security is a big issue. Every phase you have to take care of security. So here also in the gateway you should have firewall, and most importantly the gateway must have a processor. Otherwise, we don't need the gateway. And the processor can do some rudimentary kind of processing, not, very complex processor. This should be low cost processor. Okay. Like as I said, that these will be just these kind of boards. Edison, Galileo, Arduino, Raspberry Pi, Beagle board. So these will be like this. So after that, you can send it to the internet. But why this fog processor? Because we do not want that. What we need is large number of intermediate processing can be done by the fog processor. For example, the statistical computation. Whatever data is coming, we can find out the temperature, the mean temperature, average temperature, the maximum temperature, the minimum temperature, the overall, how much amount of variability in the temperature in the form of variance, pressure similarly, other kinds of things. And then what is the co-variability, whether there is any correlation between temperature and pressure, whether there is any correlation between the energy consumption and the outside ambient temperature. All these smaller things can be done by the fog processor. Fog processor, then, they are more complex than the gateway or the hub. Okay, and they can do lots of complex, pre-processing and part of analytics, as we say. Because ultimately, from all these billions of sensors, whatever data is going, what is our ultimate objective is to do the analytics to find out essential information from them. So let's see that this is an IoT and cloud computing for industrial systems. There are, huge number of industrial sector. As I said, earlier, the industrial IoT is heralding a very new age. We call it as Industry 4.0. All the industries, either they implement Industry 4.0 or they will not be able to be in the market. They will not be able to produce the things in competitive because the world is competitive. Every country is doing the same thing. So IoT has to be put in the industry. So it is known as industrial IoT because it's more of, electromechanical sensing that has to be done in the industry. Large number of electromechanical sensors are there. Simple mechanical sensors, optical sensors, huge number of optical sensors will be there. So, it's very other types of electromagnetic sensors. So these kind of sensings will have to be done, and it's a huge amount of data, and the analytics also will be to enhance the quality of the product. We have to have very good analytics. Smart buildings, as I said, is a part of the smart city projects, smart city, smart village. Vehicles tomorrow will all be networked using the sensors, and they are coming. In fact, in earlier days, we used to say that, okay, it has come to Europe or in America, it will take 10 years to come to India. Today, that is not the case. Whatever has come to Europe or America yesterday, today that gap, maybe that within 1 year, 2 years, it has to come to India. So you have to remember that unless you know the data science and IoT and big data analytics, it will be very difficult for any industry, whether it's a business house or it's a manufacturing unit, it's transportation unit, or even the government sector like energy, like environment, everywhere, healthcare, huge kind of things will be required. Now let's see the same kind of architecture. Suppose there are n number of IoT devices. Now they are connected to the gateway, as I said. Gateway, what does it do? So mainly the protocol translation, as I said just now, for from simple protocol to TCP/IP protocol, internet protocol as we call it, and then we can connect through the dotted line to the internet. Or as I said, that if you need some intermediate processing to be done, then it has to be done in the edge device. It's known as edge processor, where lots of statistical processing can be done, which you will learn what kind of statistics. It's a simple mean averaging is also statistical processing. So lots of such statistical processing will be required, and then you can, the gist of it, you can send it to the internet, because in the cloud also, internet means it goes to the cloud. In the cloud also, you, of course, you need some kind of, web socket from there to put it to the cloud. The point is, there also everything is costly. It's not very free. So you have to take care of edge device or the edge processor, which will be doing quite a lot of things. So as I said that, okay, the devices may be Raspberry Pi, Intel's Galileo board, Arduino, Beagle board, everything. And that becomes an embedded OS like Ubuntu. You can make your own gateway. So in the lab, what you can do? You can purchase the sensors, you can make your own gateway, and you can also make your own edge processor, edge device with a lot of storage, and then you can also send it to the cloud. So it's so easy and so beautifully structured one by one. Now, what do you do in the cloud? This is the most important thing. Whether the data goes directly from the gateway or from edge device, what are you going to do in the cloud? In the cloud, you have got mainly two functions. One is analytics. So you have to do lots of analytics in the cloud, because, for example, in each of these areas I talked about, there is a huge amount of not only data, some complex information has to be extracted from this data through machine intelligence to pattern recognition. So these are the areas by which you can extract a lot of information. So today's world, it is looking for information, and every kind of such information will have a pattern, a definite kind of pattern. So analytics is very important, and not only you do the analysis and stop there, what is more important is, along with the analysis, you have to show through visual means that what you have analyzed. So this is known as visualization. Okay, remember that visualization is an extremely important thing. Today you may think that, okay, let me plot a graph and we can visualize. Let me show an image, that is visualization. No, it has now gone to an absolutely different way, three-dimensional visualization. Even, the different parameters are moving, are continuously changing in each plane. So it will be multi-planar parametric change visualization. So lots of important and interesting things will have to be visualized. Because, suppose a big company, the CEO, he doesn't have the time to go through every small detail. He will tell the people that, okay, let me see this curve, or let me see this result, this analytics. So for showing the analytics, using images, using graphs, not only in two-dimensional array, two-dimensional graphics, but it should be three-dimensional or multi-dimensional visualization. Through video, through audio, through multi-dimensional graphics. So it's again another big area which will be taught out here. So again, so analytics and visualization tools I have written along with the storage cloud. In the cloud, we have to purchase the storage. I have to tell to for example, from Amazon, we are talking to them. They were initially, last year they were giving us a big, amount they were charging. But we have got our own, the computing, very good resources in our center only. But along with that, we will be hiring either from Amazon or Google the storage, which will be, the cloud. Now our cloud is not necessarily that, okay, you have to hire it from there. We can have our private cloud. In my lab only, I can have a private cloud. I can have my cloud because the industries usually, they don't give it to the cloud because of the sensitive nature of the data. But after all, cloud means once you send it, you store that data. You don't have anything, you don't have any control on that, because it is in somebody, you do not know even where it is kept. Of course, now you can know that in which country or more or less the location, but then generally you are not knowing that where your data is there and whether somebody is doing any manipulation on the data. But then it's important that visualization and analytics will have to be done properly. Let's now go to the architecture of IoT. I will be, Prosenjit, you can give me a small, bell so that I can stop in how many minutes are left. So generally, in the earlier days of IoT, we were using 3-layered architecture. One was known as perception, which is known as physical layer. As I said, ISO-SI has got 7-layered protocol. So, but in IoT protocol was much more simpler, because here the sensor's physical parameters will have to be identified. Whatever is the data you are getting from the sensor. This is known as perception layer or physical layer. Then from there it goes to network layer. Okay. Network layer, what does it do? It can connect to other such smart devices, network devices, or it can be directly in the network layer, that is a gateway, or even our edge processor. From there it can go to the other storage devices or servers in my lab only. Okay, and then or else you can send it to the cloud. Even that is also part of network layer. And then the third layer was considered to be application layer, that is the different analytics for different applications, because the applications in transportation, their analytics will not be the same as the application in healthcare. The analytics are all different. So depending upon the application area, they're different. So then came another interesting thing, which is the 5-layered architecture. Perception layer is the same as the 3-layered architecture, is the physical layer. Application layer also is the same thing. But then in between, 2 more layers they have introduced, and on top another layer they have introduced. One is known as transport layer, which is there in our ISO-SI protocol. So this is the layer which transports sensor data to the processing layer, and vice versa, such as through wireless, through 3G or 4G LAN, Bluetooth, RFID, whatever it is, any kind of wireless media. So it will be sent to the processing layer. And in the processing layer, you can store the data, you can do the analytics. So processing layer, it can be in that edge processor, it can be in the cloud, wherever it is. So this layer is known as the processing layer. Then application layer, as I said, the using different transportation is one kind of analytics, and visualization is the major things in the application layer. And finally, they have kept one more, because today is the business and money and profit. That is the main thing. That is the ultimate outcome, because whatever you do today in using this big data, everything, it should be finance is associated with that. So in business layer, the business, the profit model, the security of the data. So that is at the top level. The CEOs and the MDs of the company, they will be looking after the business policies and all. So that is at the business layer. So this is a 5-layered architecture. Again, in detail, we cannot go. So IoT protocols and fog computing. Now let's come very shortly with fog computing architecture and protocols. like say big Z, I mean, in a short time, the protocols cannot be mentioned, but then there are large number of such protocols, both long range wide area network, because in IoT, it is the wide area network which comes into play, because it's not a very small area which you are covering. For example, you think about the complete West Bengal even, or the eastern zone of India, the transportation sector is quite a long range. And then if you want to have a complete picture about the whole thing, East and Northeast India, that itself will be requiring a wide area network. So energy efficient Wi-Fi, even a large number of energy efficient
Sir, we
platforms.
have another 5 to 6 minutes, so that Professor
Oh,
Shri
only.
is already here. Yeah.
Oh, acha, okay. Then in 5 minutes, let me try to complete it. So fog
I
computing
would
is a
suggest, sir, I would
decentralized
suggest
manner.
that you continue and
Okay.
take your time. You are giving a brilliant lecture, so it would benefit the students a lot. Please continue and
No,
do it. We
no,
can
no, no.
take
You will
a
also.
slightly later entry also.
No, no,
But then it's
it's
good.
all right, because you
Yeah.
also will be doing a lot of programming exercises with them. That's very important, because whatever Professor Shengupta is doing will be of enormous, because actual implementation about everything he will talk about. So cloud computing frees the enterprise. So one of the things is, why can't we do everything in the cloud? So cloud computing, it will free the enterprise and the end user from many details. Okay, that is a good thing, because we need not be worried about anything. You give it to the cloud. But then, so this is a bliss. This is a good thing. But the bliss becomes, the good thing becomes a problem. Problem for where? For latency sensitive applications, in real time applications. In fact, while talking about, in that big data, that, that distributed system, which initially, which was suggested by Google and which has been in Hadoop, Professor Shengupta is taking. One of the things is that corresponding, the system has also been implemented by Amazon, but that is in cloud. Hadoop does not use possibly cloud, or it may use, I do not know. And then cloud means latency problem will always come. In real time, it will be difficult, because you cannot get all the data in a very short time. So where the applications require the latency sensitivity, you cannot use that. So there are, other kinds of physical constraints, energy constraints, space constraint, etc. So in fact, I had taken a small, a smart traffic light system. Say, let's take a very interesting small example. Suppose a smart lighting system. Again, as I said, that you have got a camera. The camera is continuously monitoring the amount of light. Now in the daytime, it's fine. Now around this time, when it becomes dark or evening, then the average amount of light starts decreasing. So what is needed then? One of the things is, you need a good camera, quality camera, where the camera also will have, along with it, the IR LEDs, so that it can take the IR image, infrared image. So that is good. So even if it is dark, it's not that your camera cannot work. But suppose you cannot afford, in our country, whenever you are designing something, remember that you can't say that, okay, I need this, I need that, because we have got the financial constraints. Suppose you have got a camera which is, which does not have any IR, imaging, because IR imaging means it will have additional cost. So how will you do it? So you have to do the same thing using software. So this becomes a very interesting kind of things, and you have to do it in real time. Now it is evening. Gradually, our light level, optical level is decreasing, decreasing, and decreasing. and then gradually you will have to, the background of our imaging. That means the amount of light which is decreasing and decreasing, we are going more towards night. So continuously the background is changing. So whether it's a traffic light system or a video surveillance system, background light, when it is changing continuously, then you have to write the code so that the background can be continuously modeled. So it's very interesting. Because if you cannot afford to pay money for your IRs, LEDs, then you have to take care of that kind of a modeling using your software. So using background modeling, as if continuously it's changing, but your camera should be able to really monitor that continuously without any fail. Again, in the night, it's dead night, but then your camera should be able to identify that, okay, here is the object of interest. So that's one thing. Second thing is, again, when from night it becomes, light after the sunrise gradually, so camera will adjust itself. So interesting thing is the adjustability and the adaptability in an system, IoT system. Every IoT system has to be adaptable in the sense that it should be able to continuously monitor, because your monitoring, you cannot say that, okay, my camera will take the photograph only during the daytime. That you cannot say. Everything should work for 365 days, 24 hours per day. Every minute it must work. So that is a very interesting kind of things which you have to consider. So suppose in the street light system, you have got a lot of constraints, and for doing that you need a lot of interesting algorithms. It has to do accident prevention, it has to maintain the steady flow of traffic. How do you know that there is a steady flow of traffic? Huge traffic in many places. In sector 5, when I come back from my office, at times in the evening time, oh my goodness, in near that Kingdi Ghata, there's a huge traffic. Now, if the people, the police or the transport department, if they can make an intelligent guess or an intelligent, suppose the traffic, from the image you can compute continuously that so many cars are there in the traffic. This is a very simple kind of thing. So you are taking the image continuously using a video camera, and now here the video camera, because that becomes the thing, okay, and it is network. So it's an IP camera, as it is known. So you have got an IP video camera, take the images, and then you find out or estimate the traffic. And from the estimation of the traffic, you can tell some of these traffic, some of these cars that, okay, don't take this path, take a parallel, many other roads are there. Okay, so take this road so that the overall traffic will be maintained steadily. And then collection of relevant data. Today you go to any of the offices, whether it's transportation or health, you won't get any data. This is peculiar. In our country, there's no data, nobody, because the data is kept manually. So this will give an opportunity to preserve the data and its statistical interpretation of the data continuously. And so that you can really analyze that data. You can say that, okay, on Saturday from 7 to 9, there will be less traffic in this road. On Monday, there will be more traffic. Even day-wise, time-wise, you can have a prediction. So goal is, it requires a real-time reaction or near real-time. Sometimes, real-time may not be possible, because, but then it may be near real-time, and it should relate to the collection and analysis of global data for over a large amount of period time. So global data collection through IoT is very important. Anyway, I will not take much of the time. So this was a fog system architecture. Then, I wanted to go, in fact, the way it went on, how, the Bluetooth project, each of these, whether it is a Bluetooth or Wi-Fi or Zigbee, okay. So each one of them has a large amount of information base, starting with how it started from 1994. And today's, the Bluetooth, it has come, it started with version 1.0. Now I think it has come to version 4.3, most possibly. It's there in the next one. And I didn't know, I found somewhere that it's named after Danish king Harald Blatten, who liked blueberries and who had so his liking was for blueberries. Europeans, they take it very much. So blueberries, from there the name Bluetooth came. And imagine that so many companies, Intel, IBM, Nokia, Toshiba, from 1994 to 1998, imagine that it's a, Danish company, it's a small country altogether. Ericsson, they all formed a Bluetooth group in 1998. And then IEEE 802.15.1, they approved in early 2002 based on the Bluetooth, their own protocol. So interestingly, and thereafter from 2004 onwards, it's all independent consortium. So Intel also has joined. So now it is 4, Bluetooth 1.1 to today it is 4.2. As you can see that you can send large number of packets through Bluetooth. IPv6, that protocol. So it's interesting. So every of these things, if you just see that how it has evolved from 2002, 2005, etc., 2007, then somebody may think that, okay, today we don't require this. But then you will get an idea that how gradually the concepts came, how they thought about that the reduced power has to be ensured. The reduced duty cycle has to be ensured, because all the things, it should not continuously run. It should stop first, go to the sleep mode, the sensors for some time. And then how much should be the sleep mode? How much should be the active mode? So it's very, very interesting. Anyway, sensors, I thought about robotics, I would talk about, because robotic sensors, and robotics is an area where a new kind of IoT has come. It's known as robotics IoT, okay, RIoT. There's no time, maybe later on sometime. Similarly, Bluetooth. In Bluetooth, we have got Bluetooth low energy version. Everybody, energy is a major thing. MQTT, this is a very important IoT oriented protocol, and this is being used in so many applications. So one can go through the MQTT, it has got large applications. LoRa has got a large number of applications. So IoT devices. So once you have got one IoT device, you have to think about the cost. You have to think about the duty cycle. So it's how much time it is on and how much time it is off. So O by T, that is very important. So from that, you have to find out, to reduce the power consumption or to optimize it, the duty cycle should be so much, adjusted. So O by T, there should be one formula which says that, okay, it should be like this. So these IoT technology stack, we have already talked about the local sensor area network. From the sensor, it goes to the gateway devices, gateway to the cloud state. Here we have shown that no, edge device, but then it is there to cloud infrastructure, etc. Is also the same. So I will not take any time. I'm sorry for taking a little bit of more time, because Professor Sengupta is waiting and is very important. So hardware device, software devices, communication, cloud platform, etc. So in agriculture to healthcare to business, everywhere it will be used to a large extent. I would, since I may not give any more talk, But then, in fact, Professor Shengupta, Professor Mujumdar, they know it much better. So the kind of jobs which are available as data scientists, IoT means it's an integral part of data science. So data architect, data analyst, data scientist, data engineers. So they have got the different kinds of roles. It's overlapping roles, but then they are more or less distinct. So maybe on some other day, we can talk about the distinctness of these overlapping their roles. But then in this from business understanding process to finally the deployment of the whole thing, Professor Shuman Sengupta has done it in a large number of cases. He is a very practical man, and he has been doing this for a long number of years. And incidentally, he is our student also from IIT Kharagpur. Both Professor Mujumdar and myself, we were his teacher and a very good teacher. Rohan also was our student, Kaushik, everybody. Okay, so all the best. Some of the references, because many of them have been taken from either internet or from some of the papers, all those, and and the PPTs that we showed. So I'm sorry for taking more time, but if you have got some queries, you can ask.
So anyone has any questions to Professor Ray? Someone raised his hand. I will just enable his microphone.
Okay, please explain fog processors. Okay, Windows 10 IoT core is free to, unlike Windows C of the past. Okay.
And also Rajipur Mujumdar has raised his hand. So you can share your question to Professor Ray.
Okay, so maybe that we will discuss that Windows IoT code. Okay, this is the free one next time, because now Professor Shengupta is waiting, and thank you very much.